Um, Hello, Harb. I would like to welcome you for this informal meeting or a kind of like an interview for the 50th anniversary celebration of the American Institute of Chemical Engineers Environmental Division. Along with it, we are also celebrating 50 years of the Environmental Protection Agency, the NEPA Act, as well as the Earth Day. So with that, I would like to introduce myself. I'm Debalina Sengupta. I'm the Associate Director of the TEAS Gas and Fuels Research Center. Along with that, I'm also the past chair for the Environmental Division, and it is my pleasure to welcome you for this meeting.
Thank you.
I would
My pleasure.
Like to start by asking you to introduce yourself with a brief background of your research as well as your different appointments in different areas.
Yes, I am. My name is Heriberto Cabezas, and I usually go by Herb, my colleague. And I'm a chemical engineer by training. Bachelor's, master's, and PhD. Bachelor's from the New Jersey Institute of Technology, master's and PhD from the University of Florida. My PhD was really in statistical thermodynamics and chemical physics, and somehow have ended up working on sustainability and other problems, and which is fine. At the moment, I am a professor at the Research Institute of Applied Earth Sciences, the University of Miskolc in Hungary. And prior to that, I was a professor at the Pazmany Catholic University in Budapest, Hungary. I also was, for a long time, employed at the U.S. Environmental Protection Agency for about 25 years, as it turns out. And had positions as a team leader for the team for the for the process design and team, and I was also a branch chief for the Sustainable Environments Group. A branch is a research group. I had about 18 people, and for about 2 years I was division director for the Sustainable Technology Division, about 60 people or so. And then I finally got out of management, and for the last about 9 years at the EPA, I was the senior science advisor. First, Sustainable Technology Division, and then the Materials Management Division, both in the Office of Research and Development at the US EPA. The current appointment is in Hungary, at the University of Miskolc.
So, Herb, your research has been mostly theoretical related to sustainability. So a lot of times people have a difference in understanding and opinions between sustainability and environment, or environmental and sustainable. So what, in your opinion, is the difference between the two areas? Or is there any difference? Should we try to differentiate?
There is a difference, but not a huge one. Essentially, when you talk about environmental issues, you are often focused on somewhat more specific, more immediate problems. I have air pollution, I have water pollution. What do I do? How do I treat it? How do I prevent it? When you add the dimension of sustainability, you have to stretch the time dimension quite a bit. Because not only are you thinking in terms of how do I address environmental problems that I may have in front of me, how do I try to manage these problems through time so that, 100 years from now, say, I don't have worse problems than I have today. And that's one thing. And the other thing is you also have to think a little bit about not just solving the particular environmental problem in a physical or chemical sense. You also have to think a little bit about what impact it might have on society, what impact it might have on people, and economies. So you need to stretch the boundaries a bit. So there is a difference. It's more one of emphasis, I think, on what kind of problems you are dealing with, rather than something very fundamental, like the difference, say, between reaction engineering and transport phenomena. These are really different things. These things are they're cousins, first cousins. So.
Yeah, that's very interesting. So what, according to you, has been your biggest contribution towards the science of sustainability and environment?
Probably, I think the one that has had the most impact was something called the waste reduction algorithm, which was work I did with my colleagues back in the 90s, and it's been used all over the place. It's a simple way to estimate environmental impact, the potential environmental impact of a proposed process flow sheet. I would say after that, the work on sustainability metrics it's also had a fair amount of impact. We ran a major project in the San Luis Valley in southern Colorado where we assessed the sustainable trajectory of an entire area. We did something similar in Puerto Rico. We recently did something somewhat similar in the Chicago metropolitan area. And those are applied things which I think have affected the way people think and approach problems. On the more theoretical side, I think application of information theory to environmental problems, anything from ecology to economics to societies, in particular fishery information. That's the one thing that I would say was fundamental progress in thinking, because it gives you an entirely new way to look at a problem, even problems that are still fully defined. You can still do something with it. And there is it's sort of a growing literature of people applying fishery information methodologies to any number of problems, including sustainability and environmental problems. Those are about the three things.
I completely agree with you. The WAR algorithm has been one of the leading, I would say, groundbreaking work that has laid the foundation for a lot of consequent research. But going back to your concepts of fishery information, I remember when we worked together at EPA, we had the concept of resilience that you were trying to bring in, and now resilience has a renewed meaning, if you will, in terms of how do people get back, how do societies get back. And in that sense, what I had felt at EPA was that the group that we worked with at EPA, we had different expertise that went into that. We had economists, we had law, we had different. So what do you think about this kind of convergence of researchers for working towards resilience? What are your comments on that?
Well, you have to have people from different disciplines working together on these problems, because given the human lifespan, which is somewhere around 80 years, no one has the time to develop deep expertise in economics and engineering and biology and law and so on. So the only thing one can do is find compatible people with expertise in economics and biology and engineering and society and so on, and see if you can and law, and see if you can get them to work together. That's the only solution there is. You know, if humans live 400 years, we might be able to do a series of PhDs and come out and claim, I am an expertise in law and this and that. No, we don't. We have about, on average, about 80 years or so
Mm.
do whatever it is we're going to do. So that's very, very important that you get different people and not be a cosmetic exercise. You actually have to work together.
Yeah.
It's not just a question of making up a list and saying, yeah, I collaborate. Or, no. You actually have to think together about this problem. And that is hard to do. With resilience, resilience has to do with how do you keep things from not so much getting back to where they were, but things from getting really, really bad.
Mm-hmm.
Okay, because things may never get back to where the way they were, but you just don't want them to become horrible.
Mm-hmm.
Okay? And resilience is really about making sure that things don't go from bad to horrible. Because you get, at the moment we have simultaneously something like 4 or 5 hurricanes going on in the Atlantic.
Yes.
We have enormous fires in the western part of the United States. The smoke has come all the way to Cincinnati.
Wow.
We have orange sunsets here. We have a major pandemic that we barely hold on. We have major civil disorders all over the country. And that's on top of whatever other issues may have been going on before that. So, how do you somehow manage to all these things, some of them coming together? And even if you don't get back to the way you were a year or two ago, and you sort of get through all of these issues without things descending into complete chaos and without too many fatalities or too many horrible things. And I think that's what resilience is about. So more about how do you, yes, you plan for sustainability, but how do you stay on track towards sustainability while you're being buffeted by all these different things. And so resilience is part of the thinking that needs to be done because at this point, given the large human population, which is hyper-connected physically and intellectually, we can travel all over the planet in a matter of a day or so. We pass information across the planet instantly. So anything that goes wrong, say affects you in Cincinnati, and very soon it affects you in Delhi,
mm-hmm.
and so on. The world is hyper, so it needs to magnify things. So we need to understand how do you operate under these circumstances and try to make the world more sustainable and keep it from, try to keep it down on the level of the problem. So that's my thinking.
Absolutely. And I think that's a very good thought, that we need to think more holistically and look at the resilience as a systems problem, if you will, that affects everything and everybody at the same time. And that's, I think this is a point of time in history where we are seeing a single problem hit the entire world at the same time and having the cascading effects. And on top of that, we have the dual disasters of hurricanes and wildfires. Now, in the past 50 years and most of that time you have spent at the Environmental Protection Agency, how have you seen the EPA evolve in its thought process, if you will, and where do you see the environmental protection, not the agency, but the environmental protection going forward, given that we have faced such a pandemic in the past?
Yeah, well, all right. The EPA, it's a government institution, so it it changes this way or that way around a middle line of some sort, depending on the situation. And I think sometimes we quite frankly, sometimes we slightly overregulate, sometimes the EPA slightly under-regulates, a little bit this way or that way. By and large, it's been successful, quite frankly. I mean, it has done a lot of good resolving air pollution, and water pollution, and waste management, and creating a bit of a mentality, thinking about more holistically. I mean, it's done a lot of good. It just takes time and patience, because you're trying to bring society with you, and that change is slow. I think environmental protection needs to slowly become a little bit more globalized, because it doesn't help to have a high degree of environmental protection in this particular region of the world, and the next region over, whatever that is, close or far away, doesn't have a lot. So there has to be a little bit more of a standard approach. I think that, the direction of moving in the direction of sustainability and trying to enhance resilience in some form, I think that will stay. I don't see that changing. It will evolve. It won't be exactly as you and I might have thought about it today, or a week ago, or a year ago. But in some form, it will continue to move. And one has to be careful and not too much attention to the particular gyrations of society or politics or whatever on a short term, and read too much into it. I mean, these are fluctuations, but there is a trend in a particular direction that is progressing. It just takes time. Social human change takes time. Never thought about this. Maybe about more than 10 years ago, Mexico and I were successful in getting the then administrator of NOAA, a retired Navy admiral, Conrad Lautenbacher, to come and speak at the AIChE meeting in San Francisco. At the moment, the US had not signed the Kyoto Protocols on climate change, and that was a big topic of discussion. Admiral Lautenbacher gave a very good talk, very thoughtful man. I found out, meeting and talking to him, he actually has a PhD in applied mathematics from Harvard. He's an expert in fluid dynamics, in the fluid dynamics of tsunamis. Okay. So anyway, he pointed out something that was very interesting. He said the United States didn't sign the Kyoto Protocol. Okay. That was a decision, the public decision, fair enough. However, we are reducing greenhouse gas emissions faster than anybody else, even the people who did sign the protocol. It's not like we're not doing anything, we just didn't sign the protocol. And I thought to myself, I said, he's got a point. Even when you don't agree to a formal process like the Kyoto Protocols, there's still, underneath that, there's still progress being made in the right direction, which is to have fewer emissions and so on. So don't get too agitated by we didn't sign this protocol, we didn't do this or that. Those are relatively modest fluctuations on an overall trend that continues. And that's something that one has to keep in mind.
Yeah, I think that you are hitting on a very important point there, is that it is not only the government or not only the policies that should um, guide the environmental protection. It's also to do the right thing by the people who are in the business of doing the things.
To do the right thing, and then often, I mean, I talk to people in industry, and always did, and you know, they understand it. They do, to the extent that they can. Of course, they generally do the right action. It's not, you know, it's not. You know, they have to run a business. Of course, they have to turn a profit. That's understood. But within those parameters, they often do move in the right direction. Why wouldn't they?
Yeah, and Herb, I think like one of the areas where we have seen an industry-led initiative in this sense is more of the circular economy concepts that are coming out, the Ellen MacArthur Foundation. What are your thoughts on that front? What do you think?
Look, the circular economy, you have to be careful, because strictly speaking as a scientist, you cannot have a perfect circular economy. But however, you can recycle material and energy again and again as much as possible until eventually it becomes waste that there's nothing you can do about. And what's really going on is, as you are cycling things, you are going down a free energy path. Okay, so you basically are extracting work out of the same material each path, and you develop different ways and different methodologies to extract work. That's what you're doing. Eventually, the work that can be extracted is so low that it drops below, it just doesn't have any value. It's more trouble to try extract a little bit of work than it is to let it go. So eventually you do have ways. However, instead of a one pass thing where you get resources from the environment, you make something, you use it, and you discard it. Instead of discarding it, you find some use for it. You use it one more time, maybe 2 or 3, 4 more times. And at that point, maybe after a few times, you say, well, there's nothing I can do with it. This is really waste. You've gotten 3 or 4 times the use out of it. So, and that's where circular economy is going. Strictly speaking, I mean, from a business perspective, you have invested money buying virgin resources, or maybe recycle, but you invested something in these resources into your industrial process. You made something, and then you send it out. And if you do nothing else with that material that you already paid for, you've lost some value. If you can get someone else to do it, maybe you can sell them the waste material and make a little bit of money out of it. So it's a question of conserving value, whether you do it within your own production unit or through an extended chain of other. I mean, there are businesses who claim they can turn a profit in something like 90% of what most of us would consider waste. Mm-hmm. And then so that's my thinking on circular economy. It's not exactly circular, but it's much better than one pass.
Yes, absolutely. Like there are active programs that are being taken up. Now, going back to our original, what we are celebrating here, the 50 years of the Environmental Division, we have a very vibrant group at Environmental Division. And one thing that we would like through this video is also to reach out to people who are not members of the Environmental Division to know and understand what the division has brought in terms of value over the 50 years. So both to AIChE and to the wider academic community in general. So if you can give your perspectives and thoughts on the Environmental Division.
Well, first of all, Environmental problems are the problems of this age of history. I mean, really, they are the really big problems we have are really environmental problems. If this is not done properly, we're going to be in a lot of trouble looking forward in the future. So if you want to contribute to the solution and management of environmental problems, you have to understand that you're working on probably the most important issue that we've got in front of us at this point in history. The environmental division of the AIChE is the link between the chemical engineering profession and environmental problems. This is important because chemical engineers are probably, and here perhaps I'm being a little bit chauvinistic, are probably the most versatile engineers. Let me point out that there are chemical engineers in so many places that you'd be amazed, from Wall Street investment firms to weapons lab to I mean, just thinking about this, I mean, in ecology, there's a gentleman by the name of Manowix, who does some of the best thinking in ecology, in ecosystem theory. Well, he's a chemical engineer. The person that led the team that designed and built the first thermonuclear bomb was a chemical engineer. Recently, my wife and I decided to play a little bit with stock. So we bought a book on stock trading, and I'm looking through the bio of the author of the book. Well, he's a chemical engineer. So it's important that you have any, if you have any inclination to put your skills as a chemical engineer towards the solution and management of environmental problems, that you do so. Because again, these are big problems, or the problem that we have in front of us. If this doesn't get solved, everything else is not going to matter a lot. Okay, so I would encourage young colleagues to be active in the environmental division. Once you have some familiarity with the division, run for director. If you like being a director, run for officer. Why not? You know, if you don't want to do those things, help with programming. Do something. Exactly what you do is not as important as doing something. Our own colleague, by the way, Mary Ellen Furness, who's a really successful attorney, she's a chemical engineer. So, oh, it gets better. My children's allergist is a chemical engineer. You know, he was a chemical engineer for like 10 years and then decided to go to medical school. So what I'm trying to say is chemical engineers are very, very versatile people for whatever reason. You know, so that's exactly what we need at this point in time. So yes,
I really agree with that chemical engineers are most versatile, and one of the major aspects that we deal with that probably other engineering disciplines don't deal with are high temperatures and high pressures. So that's one thing that we have unique to ourselves. How do you think, and I think we have briefly touched upon this, but how do you think the environmental field is going to progress through chemical engineering in the next 50 years, let's say? Where do you see us going? Especially this is a message for the newer generation. For example, if my child, who is a 5-year-old, if he was listening to you, what would be your message to him growing up?
Well, I think that chemical engineers need to, over time, rethink how pretty much all of engineering is done, particularly chemical engineering. We need to rethink it. Not throughout everything. That's not smart. Take a fresh look. This is because we need to be aware that material availability can change over time. Many things use rare earth metals. Those are not easy to find, and they might get scarcer as we go forward. And so how do we work in that situation? How do we produce energy and produce goods that people need at the lowest possible level of impact on the environment? How do you turn a profit? How do you run profitable, successful manufacturing processes in that environment? How do you construct engineer systems which are more sustainable than the ones they replace, in the sense that they do a better job of efficiently using material and energy, have less waste, have lower emissions, provide necessary goods and services to people, provide employment for people, for example, because people do have to do something with their lives, fit within the social and the framework in which they operate, because private firm has 2 licenses. There's a legal license. You have to meet certain legal requirements. And there's also a social license. Mm-hmm. That basically says, does the human community support your existence? And you have to have both. One is very clear, legal license. If you don't violate that, you get in trouble with the law. The other one is more subtle, but it's also real. If the human community in which you operate really doesn't like you, you're going to have problems. So that needs to be thought about. How do we make systems as resilient as possible? Because if you get a hurricane, an earthquake, a fire, what have you, what are you going to do? How do you anticipate for some of these things, or maybe even a combination of things, so that you don't have problems emanating out of these perturbations, and hopefully keep operating at some reasonable level. There are even rare events that most of us don't worry about, but they do exist, and I will give you one. In 1859, there was a British astronomer by the name of Carrington, who was observing the sun. I think it was September of 1859. And the only electrical technology at the time was the telegraph system. He observed a massive solar flare coming out of the sun through his projection telescope. This is why it's called the Carrington event. Well, when the solar flare hit the ionosphere of the planet, it produced enormous electromagnetic impulses, which create electricity in the telegraph system and took it down. The operators couldn't touch the keys without getting a shock. The keys operated on their own. Messages got lost. And the telegraph system is just a wire with 2 keys. If he could wreak havoc with the telegraph system, I can only imagine what it could do with modern electronic systems that are not shielded, heavily shielded. So one has to think that, yeah, there has only been one recorded Carrington event, so solar flares of that magnitude are rare. But it can happen. So one thinks about, I'm not going to overdo it. However, is there a cheap way to insulate the most critical elements in case I do get a huge solar flare, which can happen? You know, and if it's just a matter of some minor changes, yes, but I don't want a disaster. So we need to think about a lot of those things because our production plants are not far from people, you know, and no, we don't want the control systems in the plant to suddenly fail.
Yeah, and that also brings up a very interesting question. Coming back to chemical engineering, a lot of our work has been in the field of oil and gas, and refining and fuels and petrochemicals are our, like, that is a part of our life-sustaining materials. And a lot of our resources are in the US Gulf Coast, which currently has 5 storms formed, and we are continuously hit by these storms in the Gulf Coast being one of the most active areas for oil and gas. Do you have anything for our oil and gas friends in terms of how they can be better prepared from these kind of weather events, and how can they be resilient, if you will?
Well, I will be honest, I think the people who are working on this are smarter than I am. So I would be hesitant to say too much. I think they understand the problem. I do. I mean, I've heard enough from enough people that I think they understand there is a problem. It's going to take some time to basically fortify a lot of the production facilities against these problems. But I think eventually they will, because the alternative is very expensive. You know, you shut down and suddenly you've got all this asset sitting there with no revenue, or it may get damaged, or you may have an oil leakage. It has happened, or some other problems. I think, I have some confidence that there are good people thinking about this. And I wouldn't presume to tell someone who knows more than I do what to do. But yeah, that's an example of something that needs to be looked at, absolutely. And, you know, we're not going to stop using fuels. You know, we just need to use a bit less than we have in the recent past. People ask me, do we need to stop using fossil fuels? And my answer is always, no, not really. We just have to reduce how much fossil fuel we use. You know, if you don't use too much, it's not a problem. You know, the problem is the amount, not the fuel itself, or even the CO2 emissions. If we're emitting a bit less, then it's not a problem as far as climate or anything else.
I think that's a very, very important note, and that coming from a person who has been with the Environmental Protection Agency for such a long time is something that we all need to understand, that there is a balance. And we cannot stop the use of fossil fuels, but what we can definitely do is to reduce it and go for alternatives and better ways of utilizing it. I think the efficiency is the key factor that we have to look at.
Efficiency and supplementing it with whatever solar and wind and geothermal and whatever else we can use, efficiency and so on. I don't think this is a case where you need a radical solution that where you say, well, we're going to ban fossil fuels. No, you don't have to, nor would you want to.
Mm-hmm.
You just have to use less.
Absolutely.
So
Herb, I think we are coming to the end of our time. And do you have any concluding thoughts to take us forward?
Well, no, I mean, really, I'm an optimist at heart, I think. I think we will have difficult times. I mean, I'm old enough, I don't need to worry too much about difficult times, but I do have children. Mine are young adults. And I think eventually we may go through a bottleneck. You know, some difficult days, but eventually this will get solved. I don't think, I don't believe that. Hi, Shweta.
Hi, Herb. Hi, Devlina. So on my calendar, it was at 5:30 p.m. EST.
Might have been a mistake.
Sorry for joining in late. So I just checked the text because I was in another meeting from 4:30 to 5:30, and that's fine. I'm sorry for joining in late.
Well, no, I'm not a gloom and doom person. I don't think that the world is going to end. I think we may have some difficult times, and by bottleneck I mean periods of time when the decision space shrinks, so the options you have are limited.
Mm-hmm.
But eventually we'll come out on the other end, you know, life must go on. Yes. And you have to be careful. I should point out that, you know, the Roman Empire had a lot of problems that remind me of the problems we're having. They had problems with pandemics. They had problems with security. They had social problems. They had economic problems. They had problems with drought. I mean, it still lasted close to 1,000 years.
Wow.
You know, this state, the Roman state, went on for almost 1,000 years. Okay.
Wow.
As a major state, it lasted maybe, I don't know, maybe 700 years. And then towards the end, it was just a small piece of land in northern Greece. But so they had all kinds of problems. Similar, there is a book called The Fate of Rome, which is worth reading. It's nice. Compared to engineering, this is light reading.
Mm-hmm.
Okay, so if you're interested in a little bit of history, it's worth reading the book. Sure, they had all these problems, you know, which you don't hear about in history. You know, in history you hear, well, the Romans lost a battle. What you don't hear is that half the Roman army was sick with some pandemic. They couldn't fight. And there are things like this which you don't normally find in your run-of-the-mill history book.
Yeah, but this
they went on. They managed.
I think we are in somewhat. If you look at the bigger picture of life, we are somewhat. I wouldn't say privileged, but fortunate to have seen this kind of pandemic happen in our lifetime, because again, this is once in a lifetime event, probably. Hopefully we are going to get out of this soon.
I'm not sure it's a once in a lifetime event, you know, with the high population density, concentrated in cities with physical movement between all these cities. Yeah, we'll get more pandemics, most likely. But again, we will muddle through it.
But do you think like the population, if of course, like we have being more global and we are moving all around the world, is that a reason why this spread happened so fast?
Yes,
And
yes. And the same thing happened to the Romans.
mm,
You know, a disease would break out in Alexandria, Egypt. And within the Roman world, you could travel safely from one end to the other. So the disease is suddenly over in what was then Gaul, which is now France. The next thing, it was in Britain. And it traveled as fast as people moved, which was sail, ship, and horses. So instead of, we travel much faster than a horse now. So in our case, it goes faster, but it's just the movement of people. And the movement of people has created modern culture, which it has a great benefits. I mean, we are able to tap knowledge from anywhere in the planet. I don't want to say this is a bad thing. I'm just saying that anything you do has some sides that you need to worry about and manage, and this is one of them. Yeah.
Yeah, and again, we have seen this with many civilizations getting devastated when people from one place have moved to another place, because they bring with them. And now also, like in the remote towns of India, we were told that people are not allowing outsiders to come into those villages because they have not been touched by the pandemic and they don't want people from outside to come and infect them.
I mean, the Romans had crowded cities all over the empire. There was Jerusalem, Alexandria, what was then eventually became Constantinople, Rome, what became London, etc., etc. They were crowded, and there was easy movement between all these cities. So within a particular city, it was easy for a pandemic to spread. And because there was movement between all these cities, which was easy, relatively easy, the pandemic would spread to other cities, and then from the cities to the countryside. But it sounds familiar, actually.
Yeah.
But this kind of thing has happened before. And of course, in those days, medicine was not able to cope with this problem, so the mortalities were huge. Nowadays, it's relatively modest.
So I know we are running out of time, but if Devlina has not asked a question, can I ask one question?
Yes, go ahead.
So what would be your message, Herb, to younger generation, people like us, and also much younger, to remain optimistic? Because it's very hard to remain optimistic.
No. Don't get depressed. We will muddle through a lot of these problems, really. And understand that it's just a challenge of life. I think that at the end of the day, humans are smart enough to get through all these problems. It just doesn't look like it on a short time scale. If you expand the horizon a little bit, you can see the progress. Yeah. So don't let short-term problems bother you that much.
Because one thing I'm reading is that there has been because of this pandemic, there has been higher rates of depression among younger people, and also even suicide in developing world as well. So it's I mean, when younger students come to us and talk to us, it's very hard. If we don't have a solution, it's hard because for them, they want to have a solution right away.
Because for many of these people, it's the first time in their lives when they have a problem that does not have a solution available. Yeah. Okay. And the thing to understand is that having solutions to problems readily available is something that has only happened in the last 100 years or so. For most of human history, that was not the case. So we have the solution coming, and it might just take a year.
Right.
It might take a year. So, and it's not just the young people, the old people. Some people apparently have developed post-traumatic stress syndrome out of the pandemic.
Right.
And you know, one shouldn't. It's just the struggle of life. You have this problem and you have to have a little bit of patience.
Right.
We solve the problem and it's frustrating because we muddle through the problem. People really should wear a mask and not everybody does. You know, and you know, it's okay to individually get a little frustrated. You just can't let it make you too.
And one thing, Herb, I would like to say, and that may be something very interesting for all of us, is that we have a lot of research problems that have been created that we didn't think about in the past. So I think that is something that we have to look forward to as researchers, because that's what I did when I was feeling down and out in early March. And then we started thinking, like, what can we do? Because at that time it was a problem of medical doctors and probably politics. But after that, like, we saw the supply chains failing, and that was a problem that came out in our domain. And then, of course, we saw some environmental benefits come out of people stopping their movements and being indoors. So that can be something that we can think about in the future. But that's just a joke. Not everything needs to be inside.
Life presents you with challenges, and you say, well, let me see what I can do with it.
Yes, absolutely.
And do your best to manage it. I think that the Stoic philosophers viewed problems in life as opportunities to train in the art of living. Just like a wrestler would have an opponent, would wrestle with an opponent in the hope of becoming a better wrestler. And that's how you have to look at these things. So,
right.
All right. Well, I don't want to
thank you so much. No, thank you so much, and thank you for the wisdom. More important than all the discussions that we have scientifically, but I think it's the wisdom of looking forward and doing the resilient engineering, if you will, is something that we have to look forward to. Thank you so much.
All right. Thank you. Thank you to both of you. All right. Bye-bye.
Bye-bye.